In the fabric of our reality, time has long been perceived as a linear progression, past fading into memory, the present fleeting in the moment, and the future an enigma yet to unfold. Yet, beneath this seemingly linear construct lies a profoundly intricate and thought-provoking reality, the simultaneous existence of past, present, and future. Human perception of time has shaped our understanding of existence, but recent explorations into the depths of physics and our expanding comprehension of the universe have unveiled a concept that challenges the very essence of our temporal reality. The experiment conducted in 1971 involved flying an atomic clock around the globe and comparing its readings with a stationary one on the ground. As predicted by Einstein, these clocks diverged, differing by a mere few hundred billionths of a second, providing tangible evidence that emotions can influence the passage of time. This validation reaffirmed Einstein's theories.
Einstein's theory has been tested again and again and again, and it all hangs together. It really forms the basis for the way we understand much of the way nature works.
These effects, which used to be considered sort of obscure and very small, are very in your face with today's technology.
However, the evolution of technology has unveiled an unforeseen correlation between space and time, prompting Einstein to dismiss their separation. Instead, he conceived the fusion of space and time, coining the term space-time to encapsulate this four-dimensional amalgamation.
Einstein unified the idea of space with the idea of time into this four-dimensional structure called space-time.
This groundbreaking amalgamation led Einstein to a profound revelation. The apparent disparity between past, present, and future might be an elaborate illusion. In our daily lives, time seems continuous, yet it's also akin to an intricate series of snapshots or moments. Envisioning every single moment in the universe aligned, each earthly instant, every orbit around the sun, and each universal occurrence would reveal an exhaustive visual narrative encompassing all events, past, present, and future, across every corner of space and time. From the very start of our universe exploding into existence around 14 billion years ago, to stars forming in our Milky Way galaxy, and way back to when our planet Earth first took shape about 4.5 billion years ago. This is the big story of time. It doesn't stop there. Time keeps moving, watching dinosaurs roaming the Earth, civilizations rising and falling, and even right up to this moment, like me, thinking about space-time while working in my office. Now think about what now means. It's like a snapshot of everything happening at this very moment. For example, the clock striking noon, a cat jumping from a window, a bird flying in a faraway city, a meteor hitting the moon, or a star exploding in the sky, all happening at the same time but in different parts of the universe. These events, even though they're happening far apart, all fit into this thing we call now. It's like they're all on the same page of a giant book called Space-Time. This now page holds everything that's happening across the universe, changing the way we see this moment in the big story of time. Common sense would say that you and I and everyone else will agree on what's happening or what exists right now, moment after moment. That is, we would all agree on what lies in a given now slice. But Einstein showed that strangely, when you take motion into account, this common sense picture of time goes out the window. You see what I mean? Think of space-time as a loaf of bread.
Einstein realized that just as there are different ways to cut a loaf of bread into individual slices, there are different ways to cut space-time into individual now slices. That is, because motion affects the passage of time, someone who's moving will have a different conception of what's happening right now. And so they'll cut the loaf into different now slices. Their slices will be at a different angle.
That person who's moving will tilt the knife, will be carving out these slices at a different angle. They won't be parallel to my slices of time.
To get a feel for the bizarre effect this can have, imagine an alien here in a galaxy 10 billion light years from Earth, and way over there on Earth, the guy at the gas station. Now, if the two are sitting still, not moving in relation to one another, their clocks tick off time at the same rate, and so they share the same now slices, which cut straight across the loaf. But watch what happens if the alien hops on his bike and rides directly away from Earth. Since motion slows the passage of time, their clocks will no longer tick off time at the same rate. And if their clocks no longer agree, their now slices will no longer agree either. The alien's now slice cuts through the loaf differently. It's angled toward the past. Since the alien is biking at a leisurely pace, his slice is angled to the past by only a minuscule amount. But across such a vast distance, that tiny angle results in a huge difference in time. So, what the alien would find on his angled now slice, what he considers is happening right now on Earth, no longer includes our friend at the gas station, or even 40 years earlier when our friend was a baby. Amazingly, the alien's now slice has swept back through 200 years of Earth history and now includes events that we consider part of the distant past, like Beethoven finishing the Fifth Symphony.
Even at not-so-fast speeds,
We can have actually tremendous disagreements on our labeling of now, what happens at the same time, if we're spread out far enough in space.
And if that's not strange enough, the direction you move makes a difference too. Watch what happens when the alien turns around and bikes toward Earth. The alien's new now slice is angled toward the future. And so it includes events that won't happen on Earth for 200 years. Perhaps our friend's great-great-great-granddaughter teleporting from Paris to New York. Once we know that your now can be what I consider the past, or your now can be what I consider the future, and your now is every bit as valid as my now, then we learn that the past must be real. The future must be real. They could be your now. That means past, present, future, all equally real.
If you believe the laws of physics, there's just as much reality to the future and the past as there is to the present moment.
The past is not gone, and the future isn't non-existent. Past, the future, and the present are all existing in exactly the same way.
Just as we think of all of space as being out there, we should think of all of time as being out there too. Everything that has ever happened or will happen, it all exists.
imagine Leonardo da Vinci delicately painting the final touches on the Mona Lisa, the historic signing of the Declaration of Independence, or the first day you stepped into school. They're all threads woven into the fabric of time. Now, consider events that we see as still ahead, like the possibility of humans setting foot on Mars. From our viewpoint, it's in the future. But if all moments in time coexist, it's as real as any event in the past or present. This perspective challenges the traditional linear view of time, where the past has slipped away, the present is fleeting, and the future is yet to unfold. Instead, it suggests that every event, every moment, every occurrence in the vast expanse of time is ever present, existing simultaneously. It's an intricate tapestry where past, present, and future aren't separate threads but interconnected elements in the grand narrative of existence. With this bold insight, Einstein shattered one of the most basic concepts of how we experience time. The distinction between past, present, and future, he once said, is only an illusion, however persistent. Thanks for watching, everyone. If you liked this video, don't forget to hit the like button below and subscribe. See you in the next video.